2. What I've just been talking with the class about is right now we basically are having volumes that are touching the axis of revolution. If it's not touching, it makes it much more complicated. So what you can see here is that I have already graphed 2 minus x squared. Does 2 minus x squared technically continue like this and create a parabola? Yes, it does. And here is basically just y equals, or g of x equals 1. See, that's that graph right there. And this is basically what I'm revolving it around. So does the axis of revolution always have to be the x-axis? No, you can revolve it around any axis you want. In fact, that axis could be tilted. That makes it a lot harder. But we're going to stick with horizontal and vertical. For right now, we're going to stick with horizontal axis of revolution. Okay. And really, when you start these problems, the biggest question is what is, or how do I represent the radius? That's the biggest problem. Now, some people think this one is supposed to be revolved around the x-axis, and that's not what it says. It says about the line y equals 1. And so does everybody see where the graphs have come from? Feel familiar with those graphs? Okay. So once again, I've tried to put the disks in there so you can see them. Do you see how I'm just revolving them around y equals 1? I'm not revolving them around the x-axis. Okay, which creates problems, though, because our rectangles are only this big. But do you agree, in both cases, however tall that rectangle has been our radius, correct? But we have to find a way of representing that. And we have to find a way of representing all of them. You don't want to sit there and try and do them separately, because then you have to add them separately. If I can find one function that does them all for me, I can integrate. And so as we agreed last time, as you move along, that radius is different. Are some of them going to be the same? Yeah, but there's a lot of different lengths in there the whole time. So again, what is the radius? Well, is that going to go away from me? No, it's going to stay there. Well, we'll leave it there. If I use just the function, perhaps I'll get rid of my red here. If I use just the function, it's going to be that distance. Is that, what I just drew in green, the radius? If you just say the function, is that the radius? Is that distance? No. Is this distance right here that much? Are they related somehow? If I just say the function is the radius, if I just say 2 minus x squared is my radius, capital R, that would be wrong, because it's going to be way too big. Okay, that disk would be about that big, which is not what we have. That is not our radius. Our radius is that much. Can anybody see how they're related? It's not this much, but it's only that much. How are the two related to each other? Are they the same? No. But is there always a relationship? Yes, there is. The shorter one is always going to be one less than the bigger one. How do I know it's always one less? Because what is that distance right there? It is 1. How do I know that? Because that's y equals 1 right there. Over here, if I do this one, is this distance also 1? What if I did one over here? The distance here and then change it to there, is that distance also 1? So basically, it's this function minus 1 is your radius. It's 1 less than that. It's not quite the entire function, because the function means the y value there is what we're saying. So it's not. So what I like to do normally is clean up my radius before I even try and do anything. What is the cleaned up version of my radius then? One minus x squared is my radius in a cleaned up version, correct? Because isn't that really the first thing we did in the last one, cleaned up our radius? Okay, so that's your radius. Again, that's the hardest question to answer, because now pi's out front. From where to where is another trick question sometimes. -1 to 1, very good, because we're right here and right there. The radius is 1 minus x squared. Why would I put it in parentheses? You have to square it. And again, here's dx in your rectangles. It's dx sitting right there. You have to square it. Why? Because the formula says pi r squared times height. Oof, integrating that one by hand could be much more complicated because we have a square and a square. So you could try substitution. Unfortunately, you don't have anything there. Well, chain rules for derivative. Integration by parts, no. Which leaves us with a very simple option like last time. Let's algebraically get rid of the problem. How do we algebraically get rid of 1 minus x squared squared? Well, we'd have to square root both sides. FOIL. Yep. So 1 minus x squared times 1 minus x squared will take care of our problem. Which I will do in blue. 1 times 1 is 1. And then it'll be, does everybody see it be minus x squared and then another minus x squared? I think by now you're pretty good at the FOIL, right? And so it's minus 2x squared. Now here's where a lot of people, even at this level, will go a little too fast on their FOIL and make a mistake. It's negative x squared times negative x squared is positive or negative? Positive x to the fourth. Very good. Again, that is a place, though, let's face it. I mean, I've seen a lot of people do calculus right all day and do a simple math mistake, so please take your time. So wait a minute, now don't get lost in the problem. What is that in blue that I just wrote? Yeah, it's the radius squared, right? In a form that I can actually integrate. So let's get rid of this one because we don't really want to know how to integrate that one. But this one, well, do we have to use substitution or something for this one then, or how's that work? Do we have to use integration by parts for that? Yeah, it's kind of like just do it, right? It's just do each piece and then you're done. It's kind of like the power rule. So the volume equals pi. Let's just take care of it. What is the derivative, or excuse me, antiderivative of 1 in this case? X, because it is dx, yep. Minus. Okay, very good. It would be 2/3 x cubed because it would be 2x to the third divided by 3. Everybody remember that? Take it up a power, divide by your new power. Plus x to the fifth over 5. And again, don't forget that notation that can help you out. Any questions how I got to where we are in this problem? Once again, these can be made more complicated. You're probably agreeing with me now. The hardest part of this problem was what is the radius? How do I represent it? And it will continue to be the hardest part of these problems, the entire 7-3. Okay? The more you work at it, the better you'll get. Well, we know we got a pi sitting down here. Here's where all sorts of symbols start flying in here. Well, let's substitute in 1. Well, 1 minus 2/3 plus 1/5. And yes, I chose 1 and -1 on purpose so that it would be easier for me right now. What should I write down next? Very good. Minus whatever I get on the bottom. And that's kind of my notation here. So put -1 in, which is -1. Now you take -1 to the third. That's negative, but then it's times another negative. So it's positive 2/3. Then you take -1 to the fifth is negative, so it's -1/5. And those people that get going a little bit too fast, they see the positive 1 over here, and they see the -1 over there, and they just cross them off. And then they see the -2/3 over here and the positive 2/3 there, cross them off. But you can't do that because of the negative. But could you see somebody doing that, though? I mean, it looks very inviting that they ended up being the same thing. But take a look at the graph. Isn't it symmetric to the left and right side of that? Isn't this going to happen? You should see some of the same values because of that particular graph. So what some people do once they notice that is they basically figure out this left one and just double it because they know they're just going to add the same thing. And so you can do that if you would like. What would our common denominator be there? What, 15? So it's 15 minus what? 10 plus 3. 8 times 2 is 16. So 16 pi over 15. Again, that's why I said let's do exact answers today, just to kind of get your brains going back to that. Because it is really nice when you can just type that in, though, isn't it? I agree it is. But sometimes it doesn't hurt just to go back and do a few. So if you haven't written it already, maybe somewhere in there write, what is the radius? That's the big question here. Or how do I represent the radius? So that I can represent it for every disk, not just one. Because we could sit there and do one all day. I mean, we can figure that out. But we need them all. Any questions?